This video covers the basic concepts of harmonic motion. So harmonic motion is defined as the constant repetition of motion. Some examples of harmonic motion are like a swinging pendulum or circular motion. Our go-to example is usually a block attached to a spring. So we have a few terms that we have to define in order to accurately describe harmonic motion. The first is the equilibrium position, which is where the object would naturally want to sit. So in our block spring example, where the spring is neither stretched nor compressed, is where the equilibrium position would be. So we can say, for example, the equilibrium position would be positioned right here. To cover our next term, we are going to pull the block towards the left and stretch out the spring. The distance from the equilibrium position to the furthest the block travels is known as the amplitude, which is represented with the variable a, and since it is a distance, the unit is meters. The next term that we'll cover is the period. The period is an amount of time it takes to undergo one complete vibration, or return to its original position. For our block example, the period would be the amount of time it takes the block to go from the fully stretched position on the left, let go, travel all the way to the right, and back to this position on the left again. One important thing to also note is that period is unaffected by amplitude. This means that if I pull the mass 5 centimeters or 50 centimeters from the equilibrium position, the time that it takes to make one full vibration is always going to be the same. So the last term that we're going to cover is frequency, which we've already discussed before with electromagnetic radiation. Frequency is the number of rotations or vibrations that occur in 1 second. The unit for frequency is a hertz, which is abbreviated with a capital Hz. The relationship between period and frequency is that the period is equal to 1 over the frequency. So let's do a little example here. A spring mass system vibrates with a period of 1.5 seconds, and we want to calculate the frequency. So we know we have this relationship between the period and the frequency. So we can plug in 1.5 for the period, and then we can continue to solve for the frequency, which is 0.67 hertz.